Cybersecurity in the water distribution system. The pattern of presentation goes like this. I'll be speaking about introduction, literature review, materials and methods, results and discussions, and finally conclusion. Now to introduction. The cyberspace, which consists of millions of devices, are connected together. This is to real-time processing of data, real-time data collection, and real-time decision making. Organizations are beginning to adopt the concept of cyber physical system. Cyber physical system in the sense that the physical system are integrated into the cyberspace. So both the network components and the physical systems now communicate with each other in the cyber domain. One of such industries is the water distribution sector. The water distribution sector, they are beginning to adopt the concept of cyber physical systems, where everything is all both the physical and the network components of water distribution systems are online, and data can be gotten from them and decision can be taken on them on how water can be distributed in real time. But one of the major challenges of the implementation of such a concept is cyber attacks. Cyber attacks have been on the rise since the adoption of the cyber physical systems for water distribution system. Although a lot of intrusion detection mechanisms have been put in place in trying to forestall such attacks. So one of such approaches is the usage of using the digital objects to mimic the physical twin to forestall cyber attacks in the water distribution industry. Now, what are cyber physical systems? Cyber physical system simply means the interaction between cyber and physical components. And these cyber physical systems have been adopted by so many sectors of the world. One of such sectors is the energy sectors, where it's used to dissipate energy to consumers. One other industry where it is used is agriculture industry, where it is used for precision agriculture and farming, and also in the transportation industry. For example, in the air flight organization, the aviation sector uses it for flight simulation. Additionally, the cyber physical system is also used in the healthcare industry to majorly to enhance patient care, to improve efficiency in service delivery, and lastly to ensure the safety of patients. But the major challenge of implementing the cyber physical system in the health industry is cyber attacks. And the cyber attacks upon the sector adopting so many frameworks, such as a framework that was proposed in 2014 by the National Institute of Standards and Technology in 2014. Cyber attacks have also been on the rise. In 2022 alone, 1,463 attacks were reported cyber attacks were reported in a week. Okay, now to literature review. Moving to the next section of the presentation, which is literature review. I'll be looking at the work of Zhu et al. 2021, who adopted the concept of digital twin for anomaly detection. The methodology used was they used the generative adversarial network and the time automation machine in generating their digital twin. But the limitation of the study is that the framework that was profiled is not available for, and the data sets are not available for reproducibility. Also, the work of Pagese 2021, whose aim was also to design a security architecture for intrusion detection for industrial control systems, with a case study of an industrial filing plant, had a limitation of applying machine learning, though it was applied on offline. That means real-time decisions could not actually be taken. Now to the work of Murillo et al. Murillo et al. Also adopted the concept of there's some of DALSIM, that is digital hydraulic simulator, the belt digital hydraulic simulator to simulate the physical to simulate the physical object using a sit-down water distribution system as a case study. The disadvantage of work of Morelli et al. Is that the behavioral analysis was not conducted between the physical object and the digital object to ascertain the behavior of both the physical object and the digital twin. Now to the objectives of this presentation. First, I'll be adopting I'll be adopting DALSIM from the work of Morelli et al. 2021, and first, my objective was to be to establish if DALSIM mimics the physical test bed by using an attack to understand the behavior of sensors actuators during operations, which is behavioral analysis. Secondly, I will try to profile a machine learning model for intrusion detection in the water distribution system. Now up to materials and methods. Okay, I profiled a framework, a conceptual framework in trying to improve intrusion detection, and the framework is as shown on the screen. First, the cyberphysical, the G2 twin actually, the G2 twin gets information from the cyberphysical system and tries to mimic its physical counterpart. So data sets are gotten from the two objects. When data sets are gotten from the two objects, the data set that is gotten from the cyberphysical system is used as a baseline data set, which is now used to generate a similar data set using the parameters available in the digital objects. That's the DALSIM. So upon getting a single data set, we'll now move to the anomaly detection, anomaly-based intrusion detection, where there will be class balancing of the data set to balance the number of intrusions and normal operating, the number of attacks and non-attacks to improve machine learning. And the data set will be divided into training data set and testing data set. Subsequently, machine learning algorithms such as random forest will apply on the training data set and subsequently tested to see how it performs. Additionally, standard evaluation metrics such as F1 score, precision, and accuracy is also applied to ascertain the performance of the machine learning algorithm. Upon doing that, the anomaly detection model is now able to tell us if there's an abnormal operation or there's a normal operation, and feeds that information to the digital objects, which is now subsequently moved to the cyberphysical system. Okay, in order to improve the quality of the data set that is being generated by the digital object, when the data set is actually gotten from the cyberphysical system, both data sets are standardized because of the variations in their measurements. So they are standardized. When they are standardized, then the latence variable identification is applied, which helps to identify hidden or observable variables in the data set. Then outlier detection, outlier analysis is carried out on the data set to see how the data set, if there are outliers in variables, in variable pairs from the two data sets. Then the mean absolute error is also applied on the variable pairs of the data sets to see the difference between the predicted and the observed values. Subsequently, mean central measures of dispersion and central changes are calculated. This will help to identify the difference between the values of the digital twin data set and the physical twin data set. Upon getting those values, we'll now integrate those values back into the digital twin to generate a data set, so that the data set that is generated will be much more closer to the physical object. Now, to mimic in order to conduct a behavioral analysis, the first thing that I did was to assume that the attacker has access into the cyber-physical system of the digital twin. So the study assumes that the intruder or attacker has access to the cyber-physical system. Additionally, the system that was used in implementing the digital twin is a Dell Precision 3561 system that has a 500 gigabyte of storage with an Ubuntu operating system, and the Dalsim architecture is now installed on the Ubuntu platform. Now, for the attack, the first attack that was implemented was shutting down a valve maliciously. This attack occurred for 25 minutes, and the same attack was also implemented on the digital twin for 1 hour 18 minutes. So a valve which is available on the physical twin is also mimicked on the digital twin to see how it performs. Upon conducting behavioral analysis, that is trying to establish how the physical object behaves when there's an attack, and a similar attack on the digital twin when the attack when there's a similar attack. The study was able to come out with a graphical representation using Python. Now, when the valve is actually turned off, there's an increase in the level of the primary tank in the physical test bed. Subsequently, when the same attack was implemented on the digital twin, it was also realized that the value of the tank, of the primary tank in the digital twin, also increased. So, using visual comparison between figures 4 and 5, that's this figure and the figure from the previous slide, you can see that such attacks are similar and they behave alike when implemented on the digital. Now, results and discussion. I tried to establish on the digital twin dataset. I implemented a one-dimensional convolutional neural network model on the dataset, and I came out with the following indices. I came out with an accuracy of 94.14, a precision of 93.33, a recall of 97.44, and an F1 score of 98.53. I also moved on to apply random forest, which is another model, to see how it also performs on the dataset. And it came out with an accuracy of 99.72, a precision of 99.75, a recall of 97.31, an F1 score of 99.74. Now, comparing the existing and profiled approaches, the work of Zhu et al. 2021 profiled models for intrusion detection with the following indices. Zhu et al. Applied LSTM, CUSTM, that is long short time memory cumulative sum algorithm on the WADI dataset, and came out with a precision of 61.40, a recall of 69.76, and an F1 score of 65.96. They also went further to apply the algorithm on multi-analysis decision generative adversarial network algorithm on the WADI dataset, and came up with 43.21 for precision, 95.27 for recall, and an F1 score of 59.46. Zhu et al. Also profiled a digital twin model and came up with the following indices: a precision of 66.59, a recall of 84.41, and an F1 score of 74.45. Now to my profiled approach. I profiled them using a 1D DCNN. I got a precision of 99.33, a recall of 97.74, and an F1 score of 98.53. Then applying random forest on the dataset generated, I got a precision of 99.75, a recall of 99.31, and an F1 score of 99 points. So which this simply implies that the random forest model performs very well on the data sets generated from the digital twin. In conclusion, the work profiled an intrusion detection mechanism for water distribution system in a healthcare facility. And data sets were taken from iTrust, which was used as the baseline data set, and subsequently used for generating synthetic data set. In an attempt to conduct a behavioral analysis, attacks that were implemented on the physical testbed were also mimicked on the digital twin, which showed very similar behavior. And lastly, two machine learning algorithms were implemented. One-dimensional convolutional neural network and random forest, but random forest proved to perform well in detecting normal and abnormal scenarios upon evaluation using standard performance metrics. Finally, the work preferred an improved machine learning driven intrusion detection mechanism for water distribution systems in a cyber physical systems. Thank you for listening.
Good morning, good afternoon, good evening, wherever you are. So our presentation is titled Crises, Emergencies and Disasters. That is for the conference. So cybersecurity and incident response challenges in the African continent. So we're going to be looking at specific case of the Nigerian system. Yes, as a postdoctoral researcher in IMT Minales in France, I'm also a Nigerian. Naturally. So we're going to look at that contrast of the Nigerian system and the impact on how the challenges that occur in terms of when a cyber attack occurs, how you're going to respond to those incidents, basically. So we're going to start with an introduction to the general paper topic. Then we will look at a brief background of the incidents and the reason why we wrote the paper and the research. Then we'll look at different cybersecurity strategies that have been implemented in the Nigerian system, ranging what we'll be discussing in the paper. So, and we're also going to cite some specific case studies, notable cases and examples to back up in terms of data, to back up the cases we're trying to make. And then that will be followed by some recommendations that we have extracted and proposed in order to improve the Nigerian system specifically, and then we'll conclude with a general conclusion verdict, basically. So to start off with, we'll look at incident response. Of course, there has to be a problem in terms of the cybersecurity world. So looking at the background of the Nigerian system, we have one of the highest rates of cybercrime in the sub-Saharan African region. So incident response has been growing in the number of years, starting from the enactment of laws of the Cybercrime Act down to date where we have data protection regulation as well. So incident response comes in between the lines in terms of reacting and responding to these kind of incidences to prevent them from happening, and also the investigative aspects. So the cybersecurity landscape, I think from public knowledge, we all know that different aspects of cybersecurity, including the BEC, which is the business email compromises, the scamming, has been somewhat related to the Nigerian name, with the Nigerian prince example that we're going to be given in the rest. So the landscape in the Nigerian cyber threat landscape has been on the rise, thus showing the increased importance of incident response in order to put a stop to this. One of the reasons also that contributes to this is the poor infrastructure and maintenance policies that we already have on ground, and also the inadequate legislative frameworks in terms of the laws and regulations that have been passed, both through the National Assembly and approved by the executive arm of government as well. So we're going to be looking at all these combined, ranging in the cyber resilience and incident response framework, ranging from preparation, identification, containment, eradication, recovery, down to the lessons learned, basically. So some background on some of the points that we have used. The growing number of cyber threats, ranging from the phishing attacks that have been happening, injection of malware into our financial systems, ransomware on the rise, especially in the healthcare sector, in terms of the data that has been held ransom. Now, all these attacks come with their own sets of impacts also. So the cost of these on both the national security, the image of the nation, the economy as well in terms of the numbers and money, as well as indirectly affecting the welfare of the citizens, is one of the points that we looked at. Also, when these attacks happen, mostly, as I mentioned earlier, the ability of the first responders or the first people on site when these attacks happen mostly range from lack of technical expertise, which means we don't have as much experts as we would like. Funding for training of these experts and also new experts to be developed is not there, and the support also. And then also between all the agencies, all the incident responders, all the individuals that are on site is not properly coordinated between all the stakeholders. Now, coming to the real guides in terms of policies and laws, which are bundled in the legislative frameworks and regulations, are not actually in place to address these threats directly. So this actually leaves the Nigerian infrastructure vulnerable to cyber attacks in terms of adequate policies and sets of practices, SOPs that are there to normally protect the usage of these infrastructure. So cyber threat actors take advantage of these inefficiencies and inadequacies to attack these infrastructure. So again, there's something that we call in Nigeria with the 419 scams, which is just basically an advanced fee fraud, or the Nigerian Prince scam, as I mentioned earlier. So these normally, it involves fraudulent emails or messages in order to deceive your targets or individuals, to send you money and then you won't give that particular service in exchange. So that is what we term the 419 scam. But looking at the bright side, efforts have actually been made by the Nigerian authorities and the Nigerian government in order to, back in 2015, I think the Cybercrime Act was passed in terms of prohibition and prevention, and also amended, right, in order to support especially the incident response aspect of the cybercrime supply chain, basically. Also, there was an organization or government body called the Nigerian Information Technology Development Agency, NIDA, which was tasked with the responsibility of implementing these policies. And also they came up with setting policies and strategies in order to combat these cyber attacks. So to support that also in terms of incident response, the NG cert, which is normally a cert, normally countries have CERTs, certs for incident response teams. So Nigeria also set up its own NG cert in order to add to the capability of the incident response coordinations, especially at the national level. So in 2022, last year, we had the highest record of cyber incidents, basically. So it went up by 6.85% in terms of malware. So we had examples of malware that were affecting the coin miner, the crypto mining malware, because the market in Nigeria for cryptocurrencies was booming at that time. So it was a perfect place for it to boom. Then we had an also increase in the use of botnets as well. So we know botnets are used to perform coordinated distributed denial of service attacks. So some of these botnets include the banking Trojan, which is very, very popular and also created a lot of menace within the financial industry. There was also an increase in exploits, almost approximately 95% increase in exploits that were injected. We have the Log4j, which is globally affected by not just the Nigerian case, but the vulnerability in open source Java libraries as well, that had to be updated and patched almost daily. So some of the strategies that were implemented in Nigeria in terms of all these attacks that we have mentioned, in terms of the research that we have done, So firstly, what the government did was to introduce the National Cybersecurity Policy, which is a guide for all cybersecurity individuals, all government agencies, all non-governmental organizations, in order to secure and reduce the risks in terms of their reliance in the cyberspace. Now, it actually emphasizes on three key approaches. First, the public-private sector partnership, so which means whatever data, whatever individuals they are sharing and using with the symbiotic relationship, they have to comply by the policies in the cybersecurity strategy. Now, other stakeholders, adding not only between the private and public sector, if you have multi-stakeholder engagement or international corporations like we already have in some of the universities, this also applies, and also to strengthen the governance and trust in the cyberspace, basically. So other aspects of the cybersecurity strategy includes other parts of the document in 11 parts. So the review of the document shows different doctrines in terms of your cybersecurity goals, the national security threats, not only in terms of the cyberspace, but also physical security that are perpetrated through cyber means. This also other mandates that are guiding the principles of cybersecurity, and also in terms of introducing the main arms of the government in terms of cybersecurity protection, like the NG-CERT that we mentioned, like the protection capabilities of your nuclear plants, electric grids, and so on. And this also applies in terms of online usage, which protects the use of online child abuse and also exploitation. So this is a preview of the document. It highlights mainly things that I've mentioned earlier, but just to stress here is to look at the main aspects of that support the digital economy in terms of the regulatory frameworks, and also majorly the protection of critical information infrastructure. So as all governmental bodies generate a lot of data daily, so the stresses the means of protection of its data as well. It's critical infrastructure. So basically, I look at the Cybercrime Act. These are basically law terms because we're looking at the law aspect that actually stresses the prosecution and prevention of cybercrimes in terms of its enactment. In terms of the protection of critical infrastructure, this particular aspect introduced the use of electronic communications, basically. And the Cybercrime Act also, before, at the beginning when it was enacted, it didn't include the admissibility of electronic evidence, but now it has it. And also the use of certain phenomena that have been used as tools for political enrichment. So we have seen cyber crimes that have been used in order to blackmail politicians, other individuals, all done through the cyber means, basically. So this is covered also under the Cybercrime Act. So what are the limitations, basically, of the Cybercrime Act? Looking at specifically the Nigerian context. So implementation and enforcement, basically. So you have the act. How do you enforce people to abide by these policies that have been laid down as a law, basically, because it's an act yet? Also, the jurisdiction and extradition. So, for example, if you have somebody committing cyberbullying via Facebook, now the jurisdiction, basically the servers are somewhere in Cupertino or somewhere in the US. So how do you get hold of that data to present as evidence? And how do you either extradite the person who is somewhere in Middle East or in South Asian Pacific area in order to bring him back to Nigeria and then prosecute? So those are some of the limitations. International cooperation also. So cooperations between, for example, Interpol, Cybercrime Unit, and the Nigerian NG-CERT that we had mentioned earlier, has been quite weak. So, funding also has been a problem. not only in Nigeria, but in the sub-Saharan African region as well. We also have government influence, which is common normally globally. So depending on the capabilities and the intentions of that particular regime, that will definitely influence the usage of the Cybercrime Act. Now we have sanctions and training. Now, basically, sanctions affect not only the laws of Nigeria, but its economic policies and abilities to communicate with other regions and other partners, not only in terms of the economic aspects, but in terms of data sharing and intelligence sharing. So this actually indirectly affects the usage of the Cybercrime Act. Now, finally, we have the domestic law enforcement cooperation. So we might have certain cases that will have an argument with federal agencies and local government agencies fighting for jurisdiction. Okay, it's a federal crime, no, it's a federal jurisdiction. So these are the problems that we have that are peculiar to Nigeria. Now, in terms of the case studies that we're going to look at, there are some certain incidents that are worth pointing out just briefly. So we have almost more than 82,000 data breaches from January to March in 2023, just this year, which is up quite a lot, 50,000 in the fourth quarter of 2022. So we, in terms of also the ranking, we rank really, really high, about 32nd on the list of most hacked countries because of the high percentage of data breaches that we normally have, basically. So we also had some of the biggest cybersecurity incidents just in the last 2 or 3 years. So you can see the rise and the concern that we have actually pinpointed. So in terms of some of the incidents that have happened, I'll quickly go through 1 or 2 examples. We have one of the private universities, is a Christian university, that the servers were hacked actually this year. They couldn't have access to their firewall, they lost access to it, and their website was taken over, basically. So this is a preview of what happened. So some really explicit pictures were defacing the university's website. So the impact was for more than 10 hours, I think. They couldn't have access to their websites. Payments that were going through in terms of school fees, hostel fees, accommodation, and the rest were all compromised. So they had to contact those people afterwards. And also other institutions that followed the same route also, that almost had the same kind of attack, include the Nnamdi Azikiwe, Ahmadu Bello University, which were all breached within the same time frame as well. So moving on from the educational institution back to banking institutions, which is a very high target in the country. According to the FITC, the enormous loss of about almost $3 billion due to fraud was recorded actually in the second quarters of last year. Now,
Ahmed, yes. You have just 1 minute to finish off.
Okay, so I will just run up briefly. So going through some notable cases, we already explained earlier what BEC is, which is basically some of the costliest frauds in the world. So we have that in abundance mostly, which is very dangerous. So one of the examples was the Silver Terriers activities, which was also stopped by the Interpol and the FBI and the Nigerian police in 2015. Another example is Invictus Obi, which was a renowned Nigerian entrepreneur, so-called, in quotes. So he was even named in Forbes magazine, but later on, after investigations, he realized that the sources of his funds were a lot of phishing attacks and fraudulent emails that were sent to people and also to get goods. So in terms of the incident response mechanism that will be put in place, will be ranging in the incident response lifecycle, ranging from preparation, detection, containment, and activities that are going to be carried out post-incident. So the major challenges that we realize here are the users, the processes, normally the lack of SOPs that they don't have, lack of general awareness, the context in which the incident happened also is very peculiar to the country, lack of experts or low number of certified experts. The laws also need to evolve, not really change, but to evolve, to adapt to what is happening currently. And also, we know that all habits die hard, so change is really difficult for many people. So to round up some of the the recommendations we propose is to give some few changes to the regulations in enhancing, increase and investing in awareness and education, and also some training. We need to embrace new technologies. We need to implement, so we already have them, just implement incident response plans and also improve the general protection of our critical infrastructure. We need to engage in partnerships with all stakeholders, basically, including the international community. So just to conclude, the major consequences that we have in Nigeria also are resulting from the data breaches that we normally have. So, and the impacts also are loss of data, financial losses, and also majorly what I will stress here is the reputational damage that Nigeria has suffered over the last 10 years. Yes. So we have looked at some of the laws and the policies that have been developed, but that is not just enough. We need to have an action plan in order to take action on what to do when an incident happens, and also involvement of all stakeholders when both developing the laws, implementing it, and in terms of compliance as well. The government is going to play a very, very big role because lawmaking is the governmental thing.
Thank you, everyone. I hope you can hear me fine, and greetings from Norway. I'm very excited about this new development that we are seeing in the field of artificial intelligence, which we call as foundation models. And I am sure that many of you heard about the buzz of AI around last year, November, when ChatGPT became a viral application all over the world. And I think, around that time, or maybe a couple of years, if we go in the background, we know that an architecture, transformer architecture in the field of AI around 2017, which was shared by some researchers in Google, started a new wave in the field of AI where people started to train models with a lot of data at the internet scale. And sooner or later, this word got popular, which is called as foundation model. And today we are talking about, is there a scope for this community to take advantage of foundation models for training a generalist emergency response and disaster management AI? Meaning, end of the day, if you are a disaster management or an emergency management professional, would you have some kind of a chat-based assistant or an AI that can help you, devise plans and strategies that can help you get out of it? So I'm not doing this alone. I have Kyle with me, and it was a bit of collaboration between Kyle and myself. Around the same time when these foundational models were getting popular, we were starting to talk to each other. I'm not a disaster management expert, so I'm only going to talk about the AI aspect, and Kyle is a domain expert, and he will talk about those topics. So I'll just take maybe 4 or 5 minutes, and then I will hand over to Kyle. So essentially speaking, to start with, what is a foundation model? So if you ask this to ChatGPT, this is what I asked. You can see on the left, it gives a longer definition. But what I like more is the definition from the Stanford's Center for Research on Foundation Models. And how they define a foundation model is that they say that a new successful paradigm of building AI has emerged, which is train one model on a huge amount of data and adapt it to many applications. And this kind of a model, what we are calling as a foundation model. And if you try to visualize it, basically it takes a lot of data, what we call as multimodal data, text, image, speech, structured data, 3D signals, all kind of data when it is trained. And when we have a foundation model, something like what ChatGPT is using, GPT-3, GPT-4, for example, is a foundation model. And what are the kind of tasks these foundation models can do? They can do question answering, they can do sentiment analysis, they can do information extraction, they can do image captioning, they can do object recognition, they can do instruction following. I think for us, for our context, the most important use case here is information extraction. Imagine you have 500 or 1,000 documents which are having relevant information around disaster management, and nobody has time to go through all those documents. How about you put in a chatbot where a user who needs only relevant information can provide exact requirements, and the AI can do the job of extracting the important information, synthesize it, and presents it to the user. And this is essentially to some extent what we do in ChatGPT, but ChatGPT is very general. So what we are imagining here is a specific example. So just to give you more examples of foundation models, you can see here on the left hand side the names of many foundation models, and on the right hand side you can see the name of the companies which are providing them. I think around April this year, as Llama was leaked by Meta, that was accident maybe, but the whole ecosystem of AI changed, because in the open source especially, people started to adopt these models and started to build new applications. But what was the inspiration personally for me, and I was also exchanging notes with Kyle, is that the way we are trying to imagine a foundation model for disaster management today, somebody did the same for medical. It's also medical, like disaster management is a specialized field, and you can see this paper was published in Nature, which is a very reputed journal, and the time when I took the screenshot, it was already been accessed more than 100,000 times. And what the authors imagine in this paper is that a medical professional, for example, can chat with an X-ray image and ask using AI, where is the problem in the X-ray, for example, and things like that. But for me personally, why I'm so excited about this topic is that the first time in my imagination, that in the history of mankind, we're getting into a stage in knowledge management where you can have multimodal data, which is any kind of text, image, video, and using an AI model, you represent that information or knowledge in a universal format, what we call as a vector. And why this is interesting is that there are already running models from Facebook and other companies where you can share the sound of a bird, and it can give you the photo of the bird, that the species that was making that sound. So first time we are able to search across file formats. So you can imagine that you can describe a situation and it can give you an image which may be relevant from that text. So this is what DALI and other tools do, right? So if we take this approach, or we take this understanding that we are able to convert multimodal data into vector, and using a vector database, what we can do is something called as vector search. So we are able to find one modality of data by, let's say, writing in text or by speaking in voice. So whichever modality we are using, we are able to find data from something called as vector databases. So this now is already getting a bit complex, but here you can see a design of a application which would use semantic search and search from private data, kind of information that user would want. So if you go to, for example, Microsoft Azure today, and if you want to launch your own private chatbot, this is what Microsoft shows, a bit complicated here, but it essentially, this is how it looks like. So basically, a user asking a response, and that response is passed by an LLM, is sent to a vector database, and it is searched among the database, and a response is found and is sent back to the user. So if you're more interested in building your own applications, there are very small 1-hour courses each that I have done personally myself. So I share some links here, and I will leave now to Kyle for building on top of this, that we know that, okay, it's very easy now to build your own private chatbots, which are very good in understanding, and maybe Kyle can share with us how they can be adapted for disaster management. Over to you, Kyle. Thank you.
Thanks, Sachin. Hi, everybody. My name is Kyle King. I am the Managing Director of Capacity Building International, and we work at a niche and specific part of emergency and crisis management. Before I just jump into this with sort of how we operationalize large language models. So we're going to talk about this a little bit. I'm not as technically inclined as Sachin is and his team, but we do use large language models and other sort of tools in our work in terms of how we operationalize and use these tools to our advantage. And we work at the intersection of what we call crisis, conflict, emergency management. We use emergency and disaster management to increase stability for societies and create more resilient societies. And we are currently working in 4 different countries and have also recently worked in Ukraine on wartime resilience. The key thing that I want to emphasize here is a huge caveat, which is what we're seeing today with the state of technology today, is you cannot replace the human. So these tools are absolutely fantastic, and we'll talk a little bit more about that over the next 5 minutes or so. In terms of expediting your work, they make things faster, they make things easier, they make them a lot, let us say, reduce any barrier to getting things done. If I have to write a memo and I don't really feel like it, I can just ask ChatGPT to do it, right? Or whatever the case is, and get me started. And then with some fine tuning, some instructions, some custom instructions, I can get some things in a very nice place. However, said that, you in terms of emergency and disaster management, you can never replace the human. That has got to be a human decision. There's going to be at some point in everybody's careers in terms of responding to crisis, a decision made about life and property and the value of that life and property. And that has to be a human decision. And if you start to try and replace those things, then you become subject to technology, to programming, to flaws, to bias, to perceptions, and everything else like that, which are inherently designed in the system, even though we try and prevent that. So you always, and the conditions on the ground change all the time, so you always have to have the fact that humans cannot be replaced in that equation. It is about making an informed decision. And really where these things are the most powerful is in the 80-20 rule. And I'll use 2 examples with these. One is a challenge and one is an obstacle. So the 80-20 rule being 80% of the mundane work that you don't want to do, that you find what we call friction, there's friction, you find it difficult to get started, it can help you with this, especially in these specific vectors like Sachin was talking about, where it could be, if you're in the medical field, you have a huge medical database. If we're living in the world of emergency and disaster management, exercises. It would be great to be able to go in and query a large language model about the last 10 years of exercises and what were the top 3 things that were considered as issues from the last after action reviews from all your exercises. Or what is the number 1 risk across communities in 10 different countries with this size, this demographic, this population, these risks, these hazards, these exposures. And to be able to consolidate information to enable you to make decisions is a lot easier when you have a sort of a lower bar and obstacle to be able to do that. But always keep in mind on the other aspect, which is an obstacle with the 80-20 rule, as we've even seen with our presentations here during the conference, 80% of the presentations had no technical challenges and 20% of the presentations did. Now, that means that largely when you look at aging demographics, like in Japan, for example, they're using technology to offset some of the care and needs in their society through technology. But we will always have a place, and we've mentioned it in the previous presentation, that there's age factors, there's exposure factors, there's technology, there's education factors in our societies that will prevent and limit this even as fast as we want to implement it. In addition, if we're looking at a 30% statistics in the EU, so 30% of the EU has some sort of disability access or functional need requirements that have to be addressed. Now, this may not prevent the use of operationalizing large language models, but it is a factor you have to consider in terms of how we communicate with people and the role of these tools in the way we do our work. But first, in terms of application of AI in emergency management, there's some very good examples in terms of how we can use these tools for automation. And the core reason we use it is expediting our work, making things faster. I just came from another country. We're doing a bunch of policy analysis, and I'm able to use AI tools and large language models to be able to do a lot faster policy analysis and get through my workshops a lot faster. We can use these things in terms of what we're already doing in certain ways, which is predictive analysis, earthquakes, weather patterns, all these things, large data sets, decision-making support. Running through options is something I found very valuable. running through specific scenarios. What if I change this variable? What happens? If there's a train wreck in this size of a county or this size of a city, what is the exposure radius? Well, what if I change it? Well, what are the top 3 hazards for railroads in small communities? Has there been any accidents in railroads in small communities of my size? And just being able to extract data that helps you make decisions has been very, very helpful. And we can also use it in forms of automation of emergency responses. But then we start to creep into where we are using computer-aided tools to be able to make human decisions, which can be problematic, especially legally and also in terms of life safety and public legislation. So what this really means, so the roles of these LLMs in disaster management, we really use them for resources allocation, management, information dissemination, and enhancing our communication. We're able to actually consolidate a lot of different resources and documents together to query these documents, to form opinions, and really enhance the way that we communicate and disseminate some of our information. If we want to develop a new public education and training program, then we're able to go in and build it out very quickly, as opposed to me having to think, reference documents, write something down, probably hate it, and start over again, and then have to go through and do that whole process until it gets to where I want it to be. And so these tools allow us to get started, and we say, give me a public education program. Here's what I'm thinking. Here's what I want it to be. And okay, it's done. That's a 70% solution. Okay, now take this out, put this in, make this longer. This looks better. And then you can move forward a lot faster. So it's really, really enabling the speed at which we can work. And that in turn helps you with information dissemination. One caveat here, you always, always, always have to check the work, right? So it doesn't replace deep expertise either. This is something that is really a challenge. You have to know what you're looking for in order to make the most use of these tools, which are where you're starting to see, and so I should mention it just sort of briefly, but you're starting to see what we call vertical specific large language models coming out, which are hyper-focused on singular domains. And so we mentioned the medical field, but these are really well-versed in one specific field, because you can't be everything to anybody. And if you start really developing these tools, then you start getting some not so accurate information. So there's lots of challenges in terms of implementing these in terms of, into our daily practices. I know, especially since you're in an academic environment, there's been a lot of questions about the use of AI tools and large language models in the academic environment, but there's a lot of challenges in terms of the speed of adoption, the use that it could have in our societies. So while we use it for very good purposes, one of the key issues that we see, especially coming into the future, is that, while I can use a large language model that's focused on UN disaster risk reduction, and I can take all the documents from that and then overlay that in with community demographics and community details and information, all publicly sourced, what I can do is I can start to get a very nice profile of a community, of a country, of a nation. But at the same time, if I start identifying risks and threats and hazards in that community, we always have to keep in mind that that information can be turned into intelligence. And that's where we start to really get into some very murky gray domains. So at what line do you cross, or where's that point where information used for good purposes and good intent to make our societies much safer and to save lives, does it become a tool that you can then turn into intelligence and targeting and economic warfare and everything else that goes along with that, and including in the information space? We've heard about cybersecurity, and the information space and hybrid warfare is where a lot of people are looking at AI and wondering just how bad it's going to get. So that's sort of where we were. Just one second. I seem to have. Okay. Lost my presentation there. All right. So basically, that's where the future of the AI is. They hold a significant promise in terms of reshaping our approach to crises. Again, really accelerating our ability to manage programs, develop programs, communicate, really that foundational work. But again, we haven't yet defined the limits of them and how good they're going to be. And so therefore, you still have to be a domain expert, and you can't take the human out of the equation. And the adoption rates and how people are going to use it is still a factor that has to be determined. So with that, I'll just leave that, and pending any questions. Thank you very much.
I'm the principal of a consultancy called Thinking TIEMS, which is about harmonizing human and machine intelligence. I'm also the director for TIEMS North America. In our last presentations, we talked about the applications of artificial intelligence, and in particular, Sachin and Kyle were talking about the power of large language models and how it can help us in our jobs as emergency and disaster managers. What I'm going to be talking about is the impact of artificial intelligence on the very fabric of our society and how that presents new risks or new twists on old risks in our society that we as emergency managers need to pay attention to. So whether you're involved in emergency management administration, you're a researcher, an educator, a student, or an operator, a responder in emergency management, paying attention to artificial intelligence is something that we need to do, and you could well incorporate into your activities, because there's no question it's going to have a big impact on the way we live. So artificial intelligence has been in the news. I'm sure many of you have seen articles and headlines talking about the capabilities, such as ChatGPT passing exams, art being created by artificial intelligence, impacts on jobs. What do we do about biases associated with law enforcement and automatic detection, deep fakes threatening our democracy by using influence, and the use of AI in warfare and terrorism. And these are very important activities, and I want to explain a little bit about how we got here. How did AI come to where we are? And I think by understanding a bit about the history, you can understand some of the limitations of the technology, which we need to be aware of as emergency managers. AI really started a long time ago, and 1943, McCulloch and Pitts developed a simple mathematical model where they were attempting to explain how the human brain and nervous system works. And they looked at it as very simple units being interconnected in large numbers. And they showed that in spite of these simple numbers, they were able to do some complicated calculations. And later in the 1950s, Claude Shannon developed a maze-solving robot that works simply by a network of relays, and showed that by these mechanical means, learning could be accomplished. Later in 1955, Arthur Samuel developed a checker playing program that he programmed to play itself and improve, and it actually got to the point where it could beat Samuel himself, and showing kind of the first inklings that humans can develop programs that can outperform them. By 1982, a new kind of artificial intelligence expert systems was in vogue, and Digital Equipment Corporation used it to save $25 million a year by supporting their sales engineers in configuring systems for customers. In 1997 was a big year for AI when IBM's Deep Blue beat the reigning chess champion, leading to headlines about when is AI going to take over, which are, of course, reminiscent of things we're seeing today in the news. The Defense Advanced Research Projects Agency has long been interested in AI, in particular AI. In 2005, they had a DARPA Grand Challenge, which laid the groundwork for today's self-driving cars. And then in 2011, IBM came in again, winning Jeopardy with Watson, which was a system that based on a variety of AI techniques. Now we find ourselves today for example, in 2017, AlphaGo was developed, which is an example of a deep neural network that played Go better than the best human player. Go, as you probably know, is a board game with far more possible moves than even chess. And this development surprised a lot of people because people work their whole lives to master Go, and here we had a program that not only beat the best player, but later iterations of it even exhibited performance that far surpassed any human. So today, deep neural networks are dominated, are the type of AI that is responsible for most of today's breakthroughs. And basically, a deep neural network is very simple. It's basically, as Sachin was talking about, there's an encoding. You turn something about reality into a vector. You put it through this network that does calculations based on simple units interconnected in a very complicated way, and you produce some output. So it's numbers in and numbers out. The thing that makes this useful is that engineers have figured out how to change, how to represent things that we're interested in terms of numbers. So, for example, that input vector could represent a vocal query to Siri. It could represent a scene being seen by a self-driving car. It could represent some text that you're trying to analyze for settlement. It could even represent stock market statistics. And then the output numbers can be configured so that they represent, for example, here, a scene that a self-driving car is trying to interpret, a video frame showing the location of the objects in the image and their classifications. So these deep neural networks are mathematical entities that do this. So how today's deep neural networks can be very complex and have billions of elements. Fortunately, human beings don't have to figure out a lot of this complexity because the machines can learn them themselves. And that's done through a method of training, which basically is shown here in this diagram. It's a mathematical process whereby up to millions or billions of examples are sent through the system. A mathematical criteria called loss is minimized, and this is a numerical score that's kept track of as you cycle through the training samples. And up to millions or billions of parameters that control the calculations within the deep neural network are adjusted during this training process. So basically, the extent to which deep neural networks function well, they learn from their training data. So large language models, we were just talking about that in the previous presentation, like ChatGPT, work on using deep neural networks. So for example, if you write a paragraph on protecting critical infrastructure, it's a text string that is presented to the deep neural network, and it encodes this and processes it in a way to produce an output that is the most likely desired response to the input. So it's text strings in, text strings out. Only the text strings can be 4,000 words long, and the outputs, of course, can be very complex results. So let's talk about AI risks. The first risk I want to talk about is failure in novel situations. Because this is an example here of a problem where a self-driving car actually hit a person that was walking a bicycle across a multi-lane highway late at night. And the reason that the AI did not recognize the situation was because a situation like this wasn't represented in its training data. And because the reality is so multifaceted and rich in variety, that's bound to happen. Bias is another problem where, for example, if a particular race is overrepresented in training data, biased decisions could be made here in the case of assessing the probability that someone is a criminal. As AI is used to more and more to control infrastructure, it can be vulnerable to failures or attacks. For example, the Colonial Pipeline was hit by a cyber attack, which interrupted fuel delivery over the East Coast. Of course, AI can create more lethal weapons that can be used in war or even terrorism. Because AI can produce such convincing text, it can be used to influence and multiply those who would like to polarize and interrupt democracy, for example, as we've seen in the Russian examples of election interference. Surveillance can be a problem with privacy and creating issues with, as I said, privacy and control. And of course, unemployment. It's believed that especially these new large language models in being able to create legitimate text is going to be very disruptive in the white collar world. So how does this impact emergency management? Well, I'm going to be talking about how this impact in terms of 4 areas here. And whether as an emergency manager you operate in administrative capacity, or you're an operator and you're a responder, or whether you're engaged in engineering or in a position to influence research, you can help mitigate AI risks. So from an administration standpoint, policy, laws, and standards, they're currently being developed. There are activities in Europe, in the United States, in the Far East to create safeguards and guardrails that will prevent some of the downsides of AI. Safety protocols and procedures are something that a collaboration between operational emergency manager folks and people familiar with AI can get together and circumvent some of the problems that may occur. Exercises and rehearsals. This is an important tool in emergency management, and incorporating the failure modes or the potential downsides of AI in these exercises and rehearsals can be an important way to circumvent them. From an engineering standpoint, some of the potential risks of AI can be mitigated by actually developing, sometimes using AI technology, watchdog systems and other ways to be able to backstop, alert, and even shut down problems with AI systems going haywire. And then finally, in research, there are ways to design the AI models so that they can be inherently safer. So what I'm saying here is that we have an opportunity in the emergency management community, whether we're functioning in administration, whether in education, operators, or students, researchers, to be able to contribute to anticipate some of these disruptions that can happen because of this adoption of this transformational technology. So I encourage all of you to look at this as an opportunity to educate yourself in terms of AI and its implications, to incorporate and influence and where you can in these areas of research, administration, operations, and to consider how you can impact this very important disruption. So in conclusion, AI technology is finding increasing use throughout our societies, and there's no doubt it's going to be extremely disruptive, and the use of it carries risks. It can fail, it can have unintended consequences, and it can be used by malicious people. So what we can do as an emergency management community is help create policy, laws, and standards, develop and mandate safety protocols and procedures, simulate AI failures in exercises and rehearsals. Be aware of what this technology might happen, and engineer safeguards and alerts into our systems, and even to the extent to which we can participate and maybe even adopt as a research agenda try to create inherently safe AI systems.